Oh, so hello and welcome everyone. I'm just trying to set up the latest things. I'm sharing my screen, so hopefully you should see something. And this is part of the demo that I'll be showing a bit later on. And now I'll start the presentation, which is here. So, hello once again. My name is Erik-Berndt, and I'll be talking about reactive messaging reaching flow state today. But before I start the presentation, I'd like to talk a bit about this flow state. It's a term from positive psychology, and it's characterized by energized focus, enjoyment, and full involvement. And I can only hope that you know this feeling, have experienced it, and that you agree that it feels fantastic. Now, the thing is, psychology tells us about 4 triggers that can help you to reach this state. Firstly, eliminate distractions. Secondly, you need to work on a specific task.
Erik,
Thirdly,
hi.
Hi, how are you? Oh, I'm sorry.
Yeah, so
Is something going wrong?
yeah, a little bit. Can
Okay.
you try to turn off your presentation and turn it on again, because it shows as a half cut right now?
Okay, I'll do that. Hold on for a sec. So I'll stop sharing and I'll just try and share a screen, and then I'm trying to share like this. Is this better?
Right now, it looks better. I will drop you a message in the backstage if everything is fine, okay?
Okay, yeah, I'm not sure if I can see that right now, but hopefully. So you're seeing the presentation right now?
You see there's 20-second delay, so I cannot really tell. I will let you know, okay?
Yeah, okay, hold on for a second. I'll just go back.
No, it's still not good.
Oh dear. Is there something I can do? It's showing the top half or the bottom half of the screen. What's actually happening? Because I can't see it right now.
Okay, I'm thinking, Erik, maybe you can try to share not the presentation, but your screen window, maybe?
Yeah, that's basically what I was doing. I'll just stop sharing once again, and then share options, and then share window or entire screen, and then I'm sharing screen too.
Okay. So the option before, after 1 minute, it was okay. So I think you can repeat, and you can continue your presentation. And in a few minutes, I will see if system reacts fine, and will let you know. If not, I will join line once again. Okay.
Yeah. Okay.
Sorry for technical
I'll just
issues.
wait. Yeah. Okay. I'll just okay. That's okay. I'll just wait for a couple of seconds then.
I think you can present. I mean, people can still hear you and see half of the presentation.
Okay, cool. So, right. Okay. So, what I was saying, I'll be talking about reaching flow state. And the thing is that I'd like to talk about this flow state first, because that's the entire idea of the presentation. That it's flow state is really something cool. And there were these 4 triggers that I was just talking about. And the first was eliminate distractions. The second is work on a specific task and nothing else. The third idea is to strategically consume caffeine, in the sense that you stay awake, right? And stay hydrated, which means, you have to drink enough, or otherwise you'll just fall asleep. And that's not good. So these are the 4 triggers from psychology, and I'll come back to these at the end of the presentation. And hopefully you'll understand and see that the very same triggers also apply to reactive messaging. And after my conclusions, I'll be ready to answer any questions from the audience, okay? So let's meet first. So I'm a Java architect, and I'm a Codesmith, and I'm working at Ordina JTech in the Netherlands. And I really heart Java conferences. So once again, hello and welcome to you all, and I'd have loved to be there live on stage and see you all there and speak afterwards, but maybe next year, we never know. I'm currently contracted by the Dutch Ministry of Justice and Security, and I have a passion for big data technologies and reactive programming. And of course, you can contact me on Twitter because we can't speak.
Erik, hi.
Yep. Oh dear, once again.
I'm sorry, it's not good. Can you try just once again, turn it off and turn it on? Sometimes it works, sometimes it doesn't.
Oh dear, this is just...
I'm really, really sorry, but I think we can handle it.
Yeah, okay. Okay, we'll just try this again. Share my screen, and then I'll just switch to Keynote again, and hopefully...
Yeah, okay, continue. I will let you know if it's not good again.
Okay, cool. So I had like 3 goals in mind for this presentation. Firstly, I'd like to explain the concepts of reactive messaging, that is the building blocks and its relation to the Java 9 Flow API. Secondly, I'd like to walk through the Microprofile Reactive Messaging API and talk a bit about the relation with message-driven beans and message listeners. And thirdly, I'd like to explain about how reactive messaging can bring you into this flow state that we just talked about with a simple demo. And hopefully there'll be time enough to do that, because we're a little behind schedule. Right, so first of all, reactive. Well, my idea with regard to reactive, it used to be something like this picture.
Erik,
oh dear. Oh dear.
It is still not good. Okay, so you are sharing your presentation or your window?
I'm sharing the right screen. I have 2 monitors. I can... Yeah.
Can you share the present? It's not PDF presentation, right?
No, I can also make a PDF of it if that helps. But I don't have it as a PDF just yet. Right, all right. I'll do that then. I'll just export it to a PDF. And where do I leave that? Because this is really horrible.
Yeah, you turn off, once you will make PDF, you open PDF, and then in the system and share options, you just press not share screen, not share window, but share like PDF file itself.
Okay, I'll do that. Hold on for a sec. Yes, okay, export. And then hopefully, right. Okay. And then we have this oh dear. Okay, I have the PDF, and then I'll go to this thing, and where am I supposed to go right now? Hold, give me a hint. Info. Share. Oh yeah, stop sharing, and then share a window. No. No, this is not good. So where am I supposed to share this PDF thing?
It on your laptop.
Oh, I can. Yeah, okay, I can do that. Sorry, preview. Yes, of course I can do that. I've got it right here. Yes, okay, then I'll just do that, and then this is horrible. Okay, and now you want me to share just the preview window? Is that the idea?
Yeah, in share options there is share.
Okay, tools, view, no thumbnails. Then just go away. Oh, view, hide, sidebar. That is so. Okay, excellent. Okay, right. Stop sharing. So I'm now going to this share options, and then I want to share a window, right? Share your screen, and then a window, and then
PDF. Yeah, try.
Then the okay, good. No, let's see if this works. Share. Well, no, this is the wrong one. Stop sharing it. Ah, this is just horrible. Share a window, and then this recent. Ouch. Yes, this is the one. Share. Can you see anything?
Yeah, I can see.
Okay, cool. Okay, well, I'll just do it like this then. Okay, so where were we? We were like here, right? So hopefully I'll just can continue right now. Okay, so my idea with this reactive used to be the same as this picture, right? What are these guys really talking about? Okay, well, just a bit a nuisance for me. So okay, we had like there are like 4 buzzwords that I would like to discuss. Hold on for a sec. So reactive programming, reactive streams, reactive operators, and reactive messaging. And
okay, Eric, it's still not good because it shows us two little windows. So sorry for all of the attendees. I see all of your comments. Everything is fine. We will manage. Just give us 1 minute. We will delay this session into morning break so you can see all of the content Eric has. So just hold on a moment, Eric. I will throw away you from the platform. Please join again to the backstage and we will go live once again. Sorry for all the mess.
Let's do that. Okay, that's okay. So I'll just leave, right?
I'll go live together with you. You can use morning break for your presentation.
Okay, thank you.
Okay, and you're live, you can go. I will let you know.
Oh, okay, awesome. So once again, hello. Sorry for all these technical difficulties that we're having, and I'll just continue, and hopefully you'll still enjoy the presentation. So what I wanted to talk about are 3 goals, right? I wanted to explain the concepts. I did this already. Like explain the concepts, walk through the API, and explain how this reactive messaging thing can bring you into flow state, which I talked to at the really beginning of the presentation. So my idea originally with regard to reactive used to be like the same as this picture. Really, what are these guys talking about? You know, they're having fun and thing, but that's about it. But I have no idea what they're saying, right? Well, reactive, you have like these 4 buzzwords, and I think it's important to distinguish between them. So firstly, we had reactive programming. Oh dear, I'm talking too fast. Sorry about that. So reactive streams. Thirdly, reactive operators. And fourthly, we have like reactive messaging. And I'll be explaining each of these terms in the next 5 minutes, which will hopefully help you to understand eventually the reactive messaging specification. Right? So, reactive programming, firstly. Well, this is a paradigm, and it's oriented around data flows and propagation of change. And you can see it as sort of the next step from the Java 8 Streams API, which brought us composition of multiple functions, and also, which is really important, lazy evaluation. So basically that means you only need to execute what's needed. So this is really important for an infinite, for a very long list that imagine when you filter it, you don't map all of these and then you discard what you don't need, but first you discard what you need and then you map something on the objects that you need. So that's the idea of lazy evaluation. But the thing is, Java 8 streams are really not suitable for reactive streams because these things are firstly asynchronous and they can be potentially infinite. And the thing with infinite streams is that they can cause memory problems if you store everything in memory. So that's not good, actually. So the second reactive buzzword that I'd like to talk about is reactive streams. And this is an initiative that started in 2013, which is a couple of years ago, of course, between engineers at Netflix, Pivotal from Spring, and Lightbend, and had like 3 main goals. Sorry, and this initiative was had this idea to provide a standard for asynchronous stream processor with non-blocking back pressure. And in other words, this means that it had 2 main goals. Sorry, I'm just a bit confused right now because of these technical things. So it had 2 main goals. Firstly, govern the exchange of stream data across this asynchronous boundary. And the second goal was to ensure that the receiving side is not forced to buffer infinite, so arbitrary amounts of data and crash, basically. And in other words, of this second thing, this is the back pressure idea. And it's an integral part of this model. And this allows the queues which mediate the data between these threads to be bounded, right? So that we don't have this infinite data. And an example for asynchronous boundaries could be like passing elements to another thread or another thread pool right? And the result of this initiative is the Reactive Streams API. And it has Java 6 as a baseline because it was started in 2013. It's really old, right? So now back to reactive programming. Right, this was this paradigm and was oriented around data flows and propagation of change. Now, didn't we get Java 9, which brought us Java util concurrent flow? Yes, we did. Of course we did. Well, let's have a look at that. Well, this Java 9 Flow API brought us 4 interrelated interfaces. Right, it has the Flow publisher interface, the subscriber, the processor, and a subscription. So the publisher is the interface where the messages are created. The subscriber is an interface which can handle interfaces. You can add a the publisher method interface has a subscribe method which can add a subscriber, 1 or more, or 10 or a million, whatever you want. And the subscriber has an onNext, onError, and onComplete methods, which are a couple of more than the Streams API has. So you have like error handling. And the subscriber has also an onSubscribe method where you can add a subscription. And this is the thing that the subscription, you can cancel the subscription when you are no longer interested in receiving messages. And eventually it has the processor method, which is basically a combination of a publisher and a subscriber, because you get message, right, and you create them. You can create a new message from the initial message. But the thing is, it doesn't have an API to map or flat map or filter or basically do anything with these things. So basically, although the Flow API, it's identical to the Reactive Streams specification that I just talked about, so this onNext, onComplete, and onError, it doesn't have this API for manipulating the streams. That thing, to do that, you need third-party libraries, which is a bit of a bummer, of course. Now, this API has been extended by the Eclipse Microprofile Reactive Streams operator specification, which is really a mouthful of whatever something, reactive. So this specification, which I've shortened to the Reactive Streams operators, because otherwise I'll just keep talking too fast to get the presentation going. It defines an API for manipulating the streams. It has similar methods to the Java 8 Stream API, the map, filter, flat map, and other things. And it also provides a service provider interfaces to allow engines to be plugged in. And this is the thing that's essential in combination with reactive messaging. This originally started as a proposal for the JDK, but it's currently in the Eclipse Microprofile specification. And it's still not ready for Java 9+, so it's still using the Java 6 APIs from the Reactive Streams API. Right. It also defines builders to create and manipulate, to create various types of streams. So it has a publisher builder, which is the thing that basically creates, is a builder for a publisher. So it's a composition of 1 publisher and 0 processors. A processor builder has 1 inlet and 1 outlet. So it's a thing that can manipulate messages. And you can compose multiple processors, so either 1 or more. And the subscriber builder has 1 inlet and no outlet. So basically it's a composition of 0 or more processors, because you can still do things with the message that you originally had, and a subscriber that consumes the eventual message, right? That doesn't seem very complicated. And you can also combine these building stages into a completion runner. So you can combine 1 publisher builder with 0 or more processor builders and 1 subscriber builder. And this results in a closed graph. So you have no inlet and no outlet anymore, because you started from the publisher builder started from nothing, and it created a message or basically a flow of messages, and the subscriber builder eventually consumes all the messages. So a closed graph. And you can run this thing. And this returns a Java 8 completion stage with the result of the stream. Fortunately, we as developers do not need to run the stream. That is where the Eclipse Microprofile Reactive Messaging implementation comes into play. Right, let's have a look at reactive messaging. This is a design concept, the fourth buzzword, reactive messaging. This is a design concept using microservices as part of reactive systems, which can interact using messages. So each of these microservices can interact with the messages that it received from other services and can generate new messages to other services. And this allows us to achieve location and temporal decoupling. And that again enables numerous benefits, such as firstly, better failure handling. And secondly, improved elasticity because we can scale out the microservices as much as we like. And thirdly, this all allows us to introduce new features more easily, which is cool because we want to keep developing software, of course. At least I do. So it's just a quick summary in between. So we need to distinguish between these four reactive buzzwords, right? So we had reactive programming, which was a paradigm. We had reactive streams, which was an initiative from Lightband, Pivotal, and Netflix. We have this reactive stream operator specification that is an API that can fill the holes in the Java 9 Flow API because you basically can't do anything without it, anything useful, that is. And fourthly, we had like reactive messaging, which was a design concept. So now we're ready to take a look at the Microprofile Reactive Messaging specification, right? So this is a specification that builds upon the Eclipse Microprofile Reactive Streams operator specification, and it's maintained by the Eclipse Foundation, right? And it provides us with a way to connect event-driven microservices. And it relies on two specifications. Right, so CDI, which comes from the Java enterprise world, and the Microprofile Reactive Streams operator specification. So the thing that brought us something that could create and manipulate messages and consume them. And altogether, this defines a development model to declare CDI beans that can produce, consume, and process messages. And where the communication between these components uses reactive streams like Kafka or MongoDB or whatever something. Now, there's an important question to ask yourself. What's really wrong with message-driven beans and JMS, which is like the old way from Java Jakarta EE, of course, right? So is there anything wrong with it? Well, actually, no, there's nothing wrong with Java or Jakarta EE only. These things were designed for a different landscape, where messaging used to be on the edge of the system, right? So we had a system that consumed messages and eventually might produce messages. Consistency in this system was handled using distributed XA transactions. So we had like this message coming in, we saved all things to a relational database, and eventually we sent away new messages, and all this was just in one huge big transaction, right? So this means message processing was single-threaded. So JMS and message-driven beans were not designed for the microservices architecture, where we have like lightweight asynchronous I/O. We have distributed message brokers that don't have XA support, and and for the architecture where we have like internal message processing, like all these microservices or CQRS that have messages flow between the application, between our components. So in this other architecture, sorry about that, apps are just built upon messages, and these messages can be external, so coming from out of the system, and internal. And they're consumed in this architecture, so the microprofile, sorry about the light going out here, right? These messages are consumed in this architecture by CDI beans, right? So how would that look like? Let's take a look at a simple flow chart where we have messages coming in from a Kafka topic and eventually going to an AMQP address. I'm really not sick. I'm just talking too much. So, and the thing with reactive microprofile messaging is that it has a declarative flow definition because we have like the CDI beans, right? So we have the messages coming in through channels, passing through beans, and eventually into an external connector. So from an external connector, which is the Kafka topic, into another external connector. So let's talk about these four things. Like we have channels, which is a channel is basically a name which indicates which source or destination of messages is used. And there are two types of channels. So we have like internal channels, And this gives us a way to implement multi-step processing by one and then another and then more. And basically what happens is what you saw here is several beans. Here we had like 3 beans that in one application form a chain of processing of the messages. And we have the external channels, which are managed by the connector beans. So the connector bean map a channel to, oh, fine. That was Siri. Thank you, Siri. I really don't need you. iPhones, they're just too smart for us people. Right, so a connector maps a channel to a remote sink or a source of messages. It manages the communication with a specific transport technology because connectors were external, right? So you can connect to Apache Kafka or AMQP brokers, and you can configure them using Microprofile config, which I'd like to demonstrate in the demo at the end of the session, and hopefully we'll still have time for that. So, right, messages, which are really important, of course, they consist of an envelope wrapping a payload. And a message will be sent to a specific channel, and it will be acknowledged when it has been received and processed successfully. And the Eclipse microprofile has a minimal implementation in the message class, and connectors can extend it to provide additional relevant metadata, such as the Kafka connector does when it adds like header information and whatever. And they're produced, processed, and consumed by methods of CDI beans, of course, right? Now, where do messages come from? Well, they're being produced. And they're handled by a CDI bean method annotated with @outgoing, and this will publish messages to a channel. So this bean publishes messages to the channel. And it looks something like this: @outgoing to a channel, in this case, the example1 channel. And we have like a message of strings that are published to it. And in this case, only one message is published, right? The hello message. Right, not really world shattering or something. But you can also produce methods using flowables from RxJava. So in this case, we have like a flowable of interval where we take 20 messages. So after every second, we start with 1 and 1, 2, 3 until 20, and that's the end of this publisher, right? Or we can also use publisher builders, which we saw at the part of the reactive operator specification, right? So we have this is a publisher builder, and it creates eventually 4 messages hello from your application. Great. Now we can consume messages as well, and they're handled by a CDI bean method, and they're annotated with @incoming. Just one thing going back, just to make sure, this last one, this may not be really useful, but you can imagine that it can be useful when you combine something of this with another message that is coming like from Kafka or something else that is really producing like this potentially infinite stream of something that you really don't know what's coming into your system, right? So this can be useful, but not like this. So now let's continue with the consumption thing. It's annotated with @incoming, and this will consume messages from a channel, right? This immensely useful message will acknowledge the message and just discard it, right? But you can do many more things, of course. You could also save something to a MongoDB or whatever you want to do with it. So message processing. Message processing, basically nothing more complicated than a CDI bean method that has both the @incoming and @outgoing annotation. And this makes it a reactive streams processor. Basically, something like this, which will, this process method will consume messages of type string, and it will create a new message with it that has the payload converted to uppercase. But of course, once again, many more signatures are supported. Right, such as the publisher builder once more. So now we can like filter the messages that are coming in from another stream. And what we're doing here is we're filtering out all the messages where the original long value is greater than 5 or less than 15, right? And this all this is going into the QA transformed channel, right? Of course. Now, this may look like sort of a maze, or as you can say, that may look complicated. So how would this help you to program more easily and be more productive? So what about this flow state actually? Shouldn't we just go back to imperative program? Well, my idea is just no, no, and no, just please don't. The thing is, you got to remember why Java 8 streams are often better than for loops, right? The imperative way of loops. We had like this functional composition where we can reuse methods across other components. And all this makes things, Java 8 streams, much more easier to understand and reason about than complicated for and while loops, right? And imperative messaging, of course, also works fine, just like for loops do. And the thing is, you have to do the plumbing because, as I said, the reactive messaging specification allowed us to have declarative messaging. So no more plumbing in the code. And it becomes complicated when you need the transformations, so the functional composition. So basically, what I think you should do is take the next step and take a look at Microprofile Reactive Messaging. Now let's do that. Currently, there are like two implementations that I have found, and like the SmallRye one, which is really active and it's maintained by people from Red Hat, I believe, and one from Lightband, which is not so active. And the latest commit that I have looked at when I made this presentation was in 2019, and it wasn't 2 years ago when I made this presentation. And it only supports Kafka, whereas SmallRye supports all sorts of external connectors such as Kafka, AMQP, MQTT, Camel, and whatever you like. So this is the one I'll be looking at. Now, when I looked at this some time ago, since then something happened, right? Let's go back to 1789, and we had like mutiny on Her Majesty's bounty, which is a famous thing in history. And SmallRye also had its own mutiny, and this SmallRye Mutiny is now the drop-in replacement for the original implementation of the reactive streams operator specification. And Mutiny still implements the specification, by the way. And the original one is now in maintenance mode. Now, Mutiny is a contraction of multi and uni, and we'll have a quick look at those two. And as I said, it's a re-implementation of the Microprofile Reactive Streams operator specification. It has additional features and a simpler API, which I like. And it also has converters to interact with other reactive libraries. So the uni is a specialized streams that only emits either an item or a failure. And this item can be null, right? And it's not possible in the original specification. And a multi can that represents the stream of data. So it can emit 0, 1, n, or an infinite number of items, and it can also have a failure event and a completion event. So the uni doesn't have a completion, it can have a failure, and it can have it has one item or null, right? This item can be null, whereas the multi, well, when there's no items, then, well, there's nothing to handle, right? When there's one item, this cannot be null, right? So that's the difference between a uni and a multi. And they have comparable methods to the publisher builders. So you can create them from items A, B, and C, and you can immediately transform them to uppercase, and you can subscribe to them with whatever something. And this gives us a multi, right? And also a uni, which you can do from one item only, and you can transform it, and you can also subscribe and do other things with it. So let's just have a look at it, and I'll have a look at the time that I have. This should be enough at time, hopefully. Oh dear, not that, right? Let's have a look, and I'll switch to the demo. And hopefully we won't get into technical difficulties again. Right, so let me just see if I can drop the presentation, and this is the thing that I'd like to demonstrate after this. So first of all, I'd like to go to this demo, and this is basically a vanilla implementation. I'll just have a look at the pom.xml where you can see what happens, what this library this contains. So it's just SmallRye Reactive Messaging, which is the provider operators. So this implements the operators, and that's basically it. It also has Mutiny RX Java, so you can and well to start it all up. So it's just a Java application with nothing under the hood, just a couple of dependencies and nothing else. And it's running on Java 11. So just have a look at the main application, and you can see what it is. Right, this is main, and has this is where it starts up. It gets a container, and it periodically sends messages to Kafka. So let's start this up, and this will give an error. And I'll tell you what happens, because I don't. Does it? Oh dear. Yeah. Just hold on, because we see, like, I was expecting. It's connected, but there's nothing. Yeah, you see here the connection could not be established. The broker may not be available, and you see that really nothing is happening here, which is and basically what I expected. And the reason is that I didn't start Kafka yet. So now I'll just start Kafka once more. And this is basically nothing more than the latest Kafka image. So a Zookeeper and a Kafka, and that's it. That's the Docker image that I'm starting. It should have started up with some luck. Right, it did. And now we'll start it again, and we'll see what happens. And hopefully, so yeah, now we see like we have received hello 0 from topic Kafka. And this is the Kafka price consumer that's of interest to us. So it's consumed to 1025. And this is the thing that's happened. And there's something coming in from prices, and we don't know what it is, right? So what's interesting to know, what is prices? And this is the prices. There's something coming from Kafka, right? And what is this? There's something producing into Kafka, which is going into prices out, right? And what's going into here is something that has a boundary of 1 and add 1,000 to everything. So there should be something between 1,000 and 1,100. And you can see here that something between 1,000 and 100 is going into there, which is good. And this is the price consumer, right? That's not what I was looking at, wanted to look at. And this is going to the prices out, and the prices out is going to the prices, right? So now let's see if something happens if I just change this, right? And you can see that this just works, hopefully. Instead of this, I'm using another interface, which is a multi of integer instead of a message of integer, right? The message interface is something from the reactive stream. Now we're just sending integers into it. So you can also do that. And basically what happens is when you do it like this, it creates a message in with a empty header, only a payload, right? So now we should see like something between 2,000 and 2,100, hopefully. And I'm doing something wrong, of course, because I'm not telling you. Every 4 seconds something happens, and we had like this metadata, and this is what happens. We convert it to, sorry, I'm still a bit confused. We had like the conversion rate is 2, and that's why it's multiplied by 2. So hopefully, if we try this again, and I'll make this a 3, and we'll restart it. Yeah, kill this. Yeah, stop and rerun. restart, it starts again. And now we have more, because now multiplying it by times 3. So it's something between 6,000 and 6,600, because we initially had something between 2,000 and 2,100 and multiplied by 3. So between 6,000 and 6,300, which happens, as you can see, right? And this is all in the configuration is done in the microprofile config.properties. As I said, this is where you configure your channels. We have like all these serializers and things that happen to make Kafka understand what's going into its topics. And we can also produce with another message instead of a multi. We can use this. We can also use the flowable, which is the thing from RxJava, and this is why. Yeah, this will not compile with like this. It should be better, right? So now we have this flowable interval. So every 3 seconds, we get something between 5,000 and 5,100, and it should be multiplied by 3 once more. And that's what we get in eventually in the consumer. So hopefully, yeah, exactly. So something between 15,000 and 15,300, right? Which makes sense. Okay. So as you can see, this demo shows us that we don't need a complicated framework like Quarkus or something, whatever. We can just have like a main application when we have the Weld implementation. Then we can combine this with SmallRye Mutiny, which implements the microprofile operator specification, and we can do all sorts of things with Kafka messages going between the application, flowing between, in this case, only one application with multiple CDI beans, which communicate with each other, right? So now I have a look at the different, a Quarkus, where you can do the same, of course, because Quarkus, as I said, Mutiny is maintained by Red Hat, and the interest in that they have in it is that all the reactive features in Quarkus are driven by Mutiny, right? So they have Mutiny. Let's have a look at the pom.xml. So basically, what have we here? We have like Quarkus, with Quarkus, right, 1.13, which is not the latest version anymore, of course, because there's something 2.0 working on that. But that shouldn't make any difference. We have like Rest Easy with all sorts of Quarkus thingies, and Rest Assured, but I'm not running any tests because this is just a quick demo. And what we have here, we have like an application, so prices.html, and let's see if we can, if something's happening here. Just hold on for a sec, because I wanted to show this first. This is, so currently we have like nothing, no messages yet, no prices yet, and now I'm starting the application, and if I'm still has nothing, so hopefully something will be happening once more. And we'll have a quick look at what's happening behind the scenes, right? And hopefully I still have some time, right? Hold on for a sec. It's not, yeah, now we see prices coming in, right? So the last price and another last price and another last price and another last price, which is something with prices, right? So once again, we have like the application, and this time we don't have the microprofile config, but we have like the application properties that has, so this is the prices.html. So there's something going into that, and with like, this is the application of properties files is where you configure the queues. The topics, of course, queues is something from old, right? So we have like Kafka once more, and integers that are going into Kafka. And where are these things coming from? They're coming from this publisher that just generates. This is the thing that creates a generated price. So something's happening here between 0 and 100. So some integer is going into that, and it's being converted into something. And we can, of course, multiply this by 10. And let's see what happens. And that I'm not really fooling you, because I'm not. So now we had something low, and now something much more. How much higher should be going? Right. So it can't be reached, but it will be in a sec. Right. 10, 9, 8, 7, 6. And we have like huge prices coming up. So basically what you see here is this is like the processor, right? So there's something coming in from the prices and it's going out to my data stream. And where is this my data stream going? This is going into the something with Rest Easy, which has the /prices, and there it goes into the stream. So this is where it's eventually produced as a plain text element. So if we have like this stream, then probably we should be able to see something like that too. Localhost prices stream, right? And let's see what we have here. So data and right, one more, and there's another data. And 1, 2, 3, 4, 5, 6, 7, and there's more data. So this is the stream of data, and this is eventually going right here, right? So basically, what we've seen here is where in Quarkus you can have also have like the prices that are going into Kafka in this case, and it's going out of Kafka, and then it's multiplied, and then it's going to an HTML file, which I think is really cool, right? So this was the quick demo that I wanted to show you because I don't have much time today. And so let's go back to the presentation, and hopefully we still have the stream. So, right. So this was the quick demo that I wanted to show you. And the lessons learned. Well, eventually, it's just like the Java 8 Streams API, right? And after some time, you'll realize the beauty of reactive messaging. We had like this declarative flow definition and all that. And eventually, this will eliminate the distractions because you only have to look at CDI beans, right, with the message. And we have like the functional composition. This functional composition allows you to work on a specific task with a clear outcome, because functions in a pure functional world, there are no side effects. So you can just do one thing and do it well, right, in your function. The good thing of reactive messaging is also that it allows the system to you can let it strategically consume caffeine, in the sense that if you need more, then you can just add extra, you can just scale out, right, and use more and add more services, so scale out your services. And of course, one important thing is to ensure that each of these services stays sufficiently hydrated, that you get the data coming in, right? And this all, if you do this, and this will bring you and your system into flow state, because exactly these are the 4 triggers that I started with when just before the presentation, right? So that's really awesome. So what I believe is really everyone from now on should leverage the Microprofile Reactive Messaging specification to build modern microservice-based architectures using the reactive stream operator specification. And with that, you get resilient, awesome, and really useful applications. A bit more useful than the demos I showed in this application, but some other time I'll hope to show you more useful applications, right? And you can use Quarkus or other microprofile implementation with it, and you can combine it with a SmallRye reactive messaging under the hood with Kafka and MongoDB to receive great effect. And now I'll take any questions. If you have like questions. Are there any questions from the audience? I'm not really sure. It's rather quiet, but maybe you're already taking a break. If I don't see any questions, let's just hold on for a sec. No. Anyone with questions? Not yet. Well, then in that case, then I thank you for your attention, and I wish you a happy and a good continuation of the conference, and I hope you'll enjoy all of the other sessions of the other presentations. Thanks, everyone. And they'll end my session. Yes.